Hi everyone, this is Siddharth, and today in this session we are going to discuss about three main concepts. One is repartition, one is max records per file, and bucketing with respect to Spark. The two most crucial concepts out of these two is repartitioning and bucketing. Max records per file is just a small option which is there as a part of partition by. So let's get started. Again, the dataset that I'm using is the same which I've used in the past two sessions of Spark. Just to give you a glimpse of the dataset, this is the dataset all about. You have a stock name, which is the name of the stock as listed on, let's say, NASDAQ. And then you have the date, and then you have the dollar value of the end of day stock value. So what it means, for example, LFL is a stock name on NASDAQ, and on 3rd of January 1997, the end of day value of the stock on Nasdaq was $2.712. So let's get started with the concept now. The first thing that we are doing here is we had this data frame. We are trying to write it to a Parquet file, and we are writing it into this path. A key concept to remember here is the file that we are going to write here is Parquet. There is another format that is key and is crucial in big data world, which is Avro, which we will be talking about later if we get time. Now, let's see what kind of a data got into this folder. How do we see that? We go to the Data Explorer. We go to DBFS. We just need to know the path, which is file store Parquet output 0. File store and Parquet output 0. And we can see here that there are 4 partitions or 4 files which are made in the file system. Now let's go down. In the next statement, we see that we are trying to see the number of partitions and the partition ID and the count of rows within each partition. So we saw in the backend that there are 4 partitions getting created, or there are 4 files getting created. Within Spark memory also, this data frame has 4 partitions, and the count of rows for each of them is shown below. Important thing to note here is the count for each and every partition is not same. They are different. For example, there is a minor gap here. We can see it has 3,765 records, and here it is close to 1,000 records extra. Again, here there are at least 700 records extra. So the count of records in each partition is not same. So they are not equally distributed. Let's look at the next statement now. So what we are doing here, we are trying to repartition our data frame into 6 equal partitions. That is what is the meaning of the word repartition into 6 equal partitions. Once we do that, we get 6 partitions of the data frame in memory, and the 6 partitions and the count is shown below. As you can see, the count is almost equal. The difference is just 1 or 2 records, not much. At the end of this command, what we are doing is we are trying to write this data frame, which is now partitioned into 6 different partitions in RAM. We are writing it into this path as a JSON file. The path is partitioned output repartition 0. Let's look at this path, what we are getting here. So we are getting 1, 2, 3, 4, 5, 6 different files, which is same as the number of partitions we had in the RAM. The same number of files are getting generated in the file system. Let's go to the next step. Now, a different thing that we are doing here, we're trying to use a command called as max records per file. So let's assume the number of records in each file is very heavy. So we want to make sure that in one file, the number of records does not go beyond this number. So for that reason, we try to use this option and give a limit here. The output goes into file store JSON output 0. Let's see the output. So as you can see here, we have 12 different files. The reason we have 12 different files here is because we have put a limit of this number here. And if you see, the number of rows in each partition is 1,97,000. We have put a limit of 1 lakh. So for each and every partition, let's say partition number 0, there will be two files created. One containing 1 lakh records, and the second one containing 97,000 records. The same pattern will be followed for rest of the 5 partitions as well. So this will give rise to 12 different files. So partition 0 has 2 files, partition 1 has 2 files, and so on. Now let's go next. Here what we are doing, we are just trying to read one of the JSON partition files which is present in this path, just to show you that the data is getting read in the same manner it was written. So date, sales, and short name. In the next step, what we are doing, we are trying to see what is the current partitions for this data frame first. So as we know, there are 6 partitions. Then we are writing it down to another path, which is JSON output partition 0. So the data will be written here. Then again, we are trying to read the data just to show you that it is getting read properly. Right. So it's just more of a repetition of the previous what do you say, statement. Right. The only thing that I feel which is changed here is, here we had a limit of max records per file in the previous statement, and now in the current statement, the max records per file option is not there. So let's see how many files got generated in JSON output partition 0. Oh, so there are so many files. The reason is we have used a comment called as partition by. So that makes a difference. We have not used overwrite, but we have used a comment called as partition by and given a value date. So that means our data in the backend file system will be partitioned based on date column. So each value of date column, let's say 1st of January 1997, will contain all the data which belongs to this date. And we know that there are 6 partitions. We are not using max records per file, so there are default 6 partitions which are here. For the next date, which is 2nd of January 1997, again, only those records which are belonging to this date will go into these 6 files, right? And so on. This continues. This is useful when you are trying to query the data based on the date column. So you are going to fetch only the data which is for that specific date for which you are querying in the where clause. Let us move next. So this is just similar stuff. We are trying to read the data. Now comes the next concept, which has to do with bucketing. So what is the concept of bucketing? Bucketing is slightly different from partitions. In what way? Let us try to see now. So if we talk about partition by, we can do it based on a column. So let's say the column is date, and let's say a date has 30 values. Let's say we only have data for January. Sorry, we have 31 values for January, right? One value for one day. That is what we have. And we only have data for January. So that means 31 values is all we have. So now we partition the data by date, right? So let's say for 1st of January, we have data for 10,000 stocks. All goes into just one file. And this one file sits in a folder which is called as 1st Jan folder. This is a simple way of explaining it. So this will give rise to 31 folders or 31 partitions in backend in DBFS in the file system. Now, what if we don't want these many 31 folders? Or let me complicate the situation. So let's say you have data for almost 10 years. right? You have data for 10 years, or let's say you have data for 100 years for January month. So 3100. Those are the number of different partitions you have. So it will lead to 3100 folders in the backend. This seems to be very high. Let's say we want to limit this because it's for the capacity of the cluster that we have. Let's say we have a low capacity cluster. We don't want 3100 partitions. We want limited number of partitions. So this limit can be applied through bucketing. What bucketing does, it uses a hash key mechanism. And based on this mechanism, we can say that all of the data for all of the dates should just go into, let's say, 2 buckets. So what would happen is all of these 3100 folders or 3100 date values, date year values will be assigned a unique key. And by using a hash, after that, it will only go into 2 different partitions, right? So it's basically used when you have huge number of partitions based on a column on which you should ideally not do partition. So let's say your capacity is very low, but still you are partitioning on a column which creates so many partitions or folders. In that case, to limit the number of partitions, we use bucketing, which still gives you the advantage of querying on the column date, but does not have so many columns, right? So that ends the concept of bucketing. With that, we come to an end for the current session. Thank you all for joining. We'll meet in the next session.